Hi everyone, I'm Behnam Gholami, and this is joint work with Vladimir Pavlovic. The goal of this paper is to do subspace clustering for time series data for which there are some time dependency between data points. Two main applications of this is human motion and action segmentation in video sequences and video scene clustering, where the goal is to sequentially cluster video frames to different scenes. In many computer vision applications, it has been shown that high-dimensional data lies on the low-dimensional structures or subspaces. So in our work, we assume that time-dependent data points lie on the union of various subspaces or structures. So the goal of subspace clustering is to partition the data such that data belonging to the same subspace are identified as one cluster. For example, in this figure, there are three-dimensional data points that, as can be seen, they lie on the three different subspaces, S1, S2, and S3. Two one-dimensional subspace and one two-dimensional subspace. As I mentioned earlier, in some applications, the order of data points matters. In this work, we utilize three non-parametric statistical models, namely the Gaussian process, the Dirichlet multinomial stick-breaking process, and the Beta-Bernoulli process, and propose a unified probabilistic model for subspace clustering of time series data. More precisely, the Gaussian process with proper kernels used to incorporate the sequential information of data points into the model, and the stick-breaking process and the Beta-Bernoulli process are used to learn the number of subspaces and their dimensionality automatically from data points. Moreover, due to the probabilistic nature of our model, we can deal with the data sets that suffer from missing data in a principal way by probabilistically marginalizing out the unseen features. This is the graphical representation of the model, where xn denotes the data points, tn denotes the time index for each data points, and cn actually denotes the cluster index for each data points. We actually developed a non-parametric EM algorithm to learn all the parameters from data. So for the experiments, we use three benchmark motion segmentation data sets, and also for scene clustering, we use two public animations. Actually, the results for the scene clustering is available in the supplementary material. In order to learn the number of subspaces and their dimensionality, we set these parameters to large value, and the model infer appropriate values for these parameters from data. Actually, in this first row of this figure, the model infers 7 and 10 subspaces out of 30 subspaces for two subject of mocap datasets. And the second row shows that each inferred subspace or cluster uses different number of bases out of 20 bases actually initially provided by the model. We also did, actually this is the clustering result for one subject of mocap dataset, where the first row shows the ground truth and the last row shows the proposed method. As can be seen, the proposed method has better performance than the other method. Actually, we also did some experiment for missing data in both missing at random and missing not at random scenarios. This figure shows the missing data result for ballet dataset. In this figure, the x-axis shows the missing rates, and the y-axis shows the accuracy and normalized mutual informations. As can be seen, the proposed method, the top one, has better performance. Thank you very much.